Okay. So, hello everyone. We are Team Spacebar, and I'm Edward, and my team consists of Litzi, Yik Heng, Alan, Kelvin, and Gladys. And today, we are going to present about SAR, which is Synthetic Aperture Radar. So, Litzi will talk about it more. So, I pass it on to Litzi.
What is a SAR satellite? It is a synthetic aperture radar satellite. A SAR satellite uses radar to create two-dimensional or three-dimensional images of objects on the Earth, such as landscapes and buildings. So, what's so special? SAR satellites are unlike traditional optical satellites that use the reflection of the sun to capture the images, much like a camera. Instead, SAR satellites produce their own energy source that reflects off the Earth and then received by the satellites. This allows the SAR satellites to measure and construct the objects on the surface of the Earth. The main advantage of using a SAR satellite is that a SAR satellite can work at night and also through clouds, whereas an optical satellite only works best in daytime and clear skies.
Sar will produce its own energy and record the reflected amount of energy from the Earth. This results in different wavelengths to be used, which are X, C, L, and P. These wavelengths from SAR can determine the radar signal's ability to interact with the surface and how far a signal can penetrate into a medium. For example, an X-band radar is a 3 cm wavelength, has minimal capability to penetrate deep into broadleaf forests, and thus it mostly interacts with leaves at the top of the tree canopy. An L-band signal has a 23 cm wavelength, which has the greater penetration into a forest and allows for more interaction between the radar signal and large branches and tree trunks. Here, it can be observed that the bigger the wavelength, the deeper the penetration. This can not only apply on the penetration depth into the forest, but also into other land cover types such as soil, ice, and other climates around the world. Thank you.
Polarization refers to the direction of the plane in which the emitted electromagnetic wave oscillates. Although the orientation can occur at any angle, SAR sensors usually transmit linear polarization signals. There are two types of polarization, horizontal and vertical, and can create four combinations of polarization. A signal which emitted in horizontal and received in horizontal polarization denoted as ##. A signal which emitted in vertical and received in vertical denoted as VV. HV is denoted by a signal which emitted in horizontal and received in vertical. And lastly, VH is denoted by a signal which emitted in vertical and received in horizontal. These four combinations help in examining the strength of the signal, which carries different information about the structure of the image surface. The VV signal normally sensitive to rough surface such as soil and water. The HH signal is a double bounce signal. The emitted signal hit the obstacles and reflect back to the radar. It normally caused by buildings, tree trunks, or inundated vegetation. HV or VH signal is a volume scattering which caused by the leaves and branches in a forest canopy. However, the penetration depth of L-band or P-band signal is much deeper, so they will experience strongly enhanced volume scattering and increased double rebound scattering caused by trunk. It's important to remember that as the wavelength changes the penetration depth of the signal, the amount of signal attributed to different scattering type may change with the wavelength. For example, the C-band signal only penetrates the top layer of the forest canopy, so it will experience roughness scattering and limited volume scattering.
I am Yik Heng, and the impacts of SAR are discussed. The most common features for the SAR satellites are that it can provide a more detailed data collections about the Earth's surface due to its 24/7 monitor systems. This is important as it helps the community to analyze climate change, ecosystems, natural disasters, and so on. An example is that it helps us to detect the severity of the flood by exploring the differences in surface refractions. Other positive impacts of the SAR satellites are that they can provide precise and high-resolution imagery, especially on the X-band type of the SAR satellites. They also provide accurate elevations models to characterize the surface features in the 3D mode. This is the end of our video. Thank you for watching.